In this demo, we're going to create and configure an Azure machine learning workspace. To do that, we're going to use the Azure portal to create a machine learning resource. We'll know it's working once we've gone through the creation cycle and we can navigate to our workspace in the portal. Before we begin, you'll need to make sure that you have access to an Azure account. If you don't, you can create one for free at azure.microsoft.com/free. Okay, so the first thing we need to do is navigate to the Azure portal in our browser. Here we are. Now let's create an Azure resource. We'll do that by clicking on the Create Resource link in the middle of the page. You can also create a resource by selecting the hamburger menu in the top left and selecting the Create a Resource option from there. Now what we want to do here is create a machine learning workspace, so let's search for machine learning. Now let's select the machine learning resource. Then we click Create to get the process started. When we're creating a machine learning workspace, we're asked for a bunch of information about that resource. In fact, the machine learning workspace actually needs a bunch of other Azure resources in order to run properly. The good news is that the setup page here asks us to choose or create those resources. So what we're going to do here is create all the resources we need all at the same time. First, we're going to create a resource group. In my case, I'm going to name the resource group sbtest-rg. Good. Next, the page asks me for a name for my workspace. Well, I'm not very creative, so I'm going to call it sbtest-ml. Now, Azure tries to be really helpful here and automatically assumes that I'm creating some new resources, and it names those resources based on my sbtest workspace name. So I'm going to leave those as is. Now, you can pick whichever region you want, but since this is temporary, I'm going to leave it as the default. Finally, we need to create a container registry. As with most things in Azure, names need to be globally unique, so I'll name my registry sbtest-ml, and then add some random numbers so it more or less matches the other resources. Besides that, we're going to leave everything else as the defaults. Good. Now we're going to skip all the rest of the tabs here and go straight to the creation step. So we'll click on the Review and Create. And assuming there's no issues, we can click on Create. Now, the process may take a little while to complete, and technically this happens asynchronously, so you can go off and do other things. But while this is happening, we'll wait for this to be done. Perfect! Now our workspace is complete. So let's navigate to it and check it out. In this case, we can do that by clicking on the Go to Resource button, but obviously that button isn't what you see when you first sign into the Azure portal. So let's navigate to it fresh. First, let's click on the Home link at the top of the page. This would be like we first signed in. Now right in the middle of the screen, I can already see my sbtest-ml machine learning resource. This is a list of your most common resources, so we could click on that right away if we wanted to, but then again, your resource may not always be in this list. So let's do this a different way. Let's click on the hamburger menu in the top left. In this menu, one of the options is resource groups, so let's click on that. Now this shows us all of the resource groups in the directory. In this case, I only have one, my sbtest-rg resource group. So find your resource group and let's click on it. Now the first thing that we see when we click on a resource group is its overview blade and all of the resources inside that resource group. And here we see all of those resources that were automatically named for us. That container registry we created with the random numbers, and huzzah, our machine learning resource. So let's click on our machine learning resource. And there we go. Our machine learning resource includes all sorts of blades with all sorts of different information and capabilities from access control to monitoring. So congratulations, you've created a machine learning workspace. In this demo, we're going to create and configure a compute instance as well as a compute cluster in our Azure Machine Learning workspace. To do that, we're going to use the Azure Machine Learning Studio tied to our Machine Learning workspace. We'll know our compute has been created when the Studio shows our instance and our cluster as running in the portal. The first thing we need to do is head over to the Azure portal in our browser. Then we're going to navigate to our machine learning resource, and I'll do that by navigating through the resource group I called SBTest and selecting my SBTest machine learning instance. Alright, so right in the middle of the overview screen we see a button called Launch Studio, so let's click on that. Launching the Studio takes us to a whole other tab in our browser. The Studio has all kinds of capabilities along the left-hand blade selection area. It's worth clicking through and seeing what's in there. But in our case, we want to focus on creating some compute capability. So let's click on the Compute blade in the Manage area. Now let's start with creating a compute instance. We're going to need a compute instance later when we execute some of our own code. First, we'll make sure that we're in the Compute Instances tab, which we are. And of course, we don't have any compute instances yet, so we're presented with a nice, easy button called Create that we can use to create our first instance. So let's go ahead and click on the Create button. Now we're going to keep this really easy. We don't need anything huge or fancy here. So for our compute instance, let's select the simplest virtual machine available. In this case, let's select the standard _D11 _V2 virtual machine right at the top of the list. And then we'll leave the rest as the default and click Next at the bottom of the screen. Next, Azure will ask us for a name for our VM. And again, since I'm not very creative, I'll just call it sbtest-compute-instance. Good, now we can click Create at the bottom of the screen and get the creation process underway. Now this may take a few moments to create, so let's just wait for it. Perfect, now we can see that our instance is being created, and that's good news. This will mean that when we go to run some of our custom code later, we'll have some dedicated compute so that we can do that. But we're not done yet. We also need to create a compute cluster. We need a cluster so that we can run some automated machine learning later and determine good models to use when we run our code. So while we wait for the instance to be created, let's switch over to the Compute Clusters tab so that we can create a compute cluster. Of course, we don't have any compute clusters yet either, so once again we're presented with a nice easy button called Create. So let's go ahead and click on the Create button. Now we're going to keep this really easy too. For our compute cluster, let's select that same simple VM we picked for our instance. In other words, let's select the standard _D11 _V2 virtual machine right near the top of the list. We'll leave the rest as the defaults and then we can click on Next at the bottom of the screen. Next, Azure will ask us for a name for our virtual machine, and again, since I'm not very creative, I'll just call it sbtest-cluster. Now notice that there's lots of settings here that you can tweak. Your cluster can have as many nodes as you want, and can even automatically scale down when things go idle for a bit. In our case, we'll set the minimum nodes to 0 and the maximum nodes to 1, and that means that we'll have one VM available in the cluster when needed. And when it's idle, it'll shut everything down, and that's good for us since we're using a free trial. Now we can click on Create at the bottom of the screen and get the creation process underway. Now this may take a few minutes too, so we'll have to wait for that. Perfect! Now we can see that our cluster is running, or at least provisioned. And if we flip back to the Compute Instances tab, well, we can see that it's running too. Excellent! Now this means that we have a machine learning workspace, a compute instance that we can run code on later, and a compute cluster so that we can run experiments. Great job! In this demo, we're going to create and configure a dataset in Azure. A dataset is basically a set of data that we can use to generate a model and train AI. So to do that, we're going to use the Azure Machine Learning Studio tied to our machine learning workspace and upload a simple Microsoft Bike Rentals dataset. We'll know our dataset has been created when we can explore it in the portal. The first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and we'll do that by navigating through the resource group I called SBTestRG and selecting my SBTestML machine learning instance. Alright, so once again in the middle of the screen we can see the Launch Studio button, so let's click on that. Perfect. Now along the left-hand side we can see a bunch of different options that we can select. Now what we want to do here is create a dataset, so let's click on the Datasets option under Assets. Of course, we don't have any datasets created yet, so we're presented with a nice easy button called Create Dataset that we can use to create our first dataset. So let's go ahead and click on the Create Dataset button. Now we're going to keep this really easy. Rather than creating our own dataset, we're going to use a Microsoft dataset for bike rentals. So in the pull-down option, let's choose the From Web Files option so that we can use Microsoft's online dataset. Alright, now we can create a dataset. In the Create Dataset from Web Files screen, we're asked for information about the dataset. So first, let's enter Microsoft's Bike Rentals dataset URL. That URL is https://aka.ms/bike-rentals. So let's just type that in. Good. Now, for a name, let's call this bike-rentals. We can technically leave spaces in the name, but sometimes Azure has issues with spaces, so let's put a dash in there to be sure. Good. Now the data is tabular, so make sure that the dataset type is tabular. And now let's click Next. Now Azure will validate the dataset to make sure it's all good. And since it's a Microsoft dataset, it should be fine. But let's wait for it anyway. Alright, now in the Settings and Preview step, you can see that it's listing a bunch of the data in the middle of the screen, and that's good. But by default, Azure thinks that datasets don't have column headings, and this one does. So let's make sure to select Use Headers from First File in the Column Headers selection. Good. Now we can leave the rest of these options as default and click Next once again. Now in the Schema step, we're given the option to choose which columns we want to include in our dataset. In our case, we want to include everything except the Path column, so make sure that all the columns are checked except for Path. Good, and now we can click Next one last time. And finally, we can click Create. Now the dataset may take a few moments to create, so let's wait for it. Alright, now we have a dataset, but let's confirm that, so let's click on the Bike Rentals dataset. And now let's click on the Explore tab. And look at that! Beautiful, beautiful data. So to recap, this means that we have a machine learning workspace, a compute instance and a compute cluster, and now we have a dataset that we can play with. Excellent! In this demo, we're going to create a dataset from files stored in an Azure storage account. To do that, we're going to create a storage account, create a file share, add Microsoft's Bike Rentals file to that file share, and then use Azure Machine Learning Studio to connect to that dataset. We'll know our dataset has been created when we can explore it in the portal. Now, being able to connect to a storage account like this is great for situations when you want to add more and more files for AI processing later down the road. Now, the first thing that we need to do is head over to the Azure portal. Now, we want to create a storage account, so let's click on the Create Resource link. Now, let's search for a storage account and then choose to create one. Now, when we create our storage account, it's important to put it in the right resource group. Now, I'm going to put mine in the same SBTest RG resource group that I've been using so far, because that will allow me to easily clean up after myself when I'm done doing all of this. Now, the storage account name can be just about anything you want, but it will have to be globally unique, and it'll have no spaces and no special characters. So I'll use my unoriginal SBTest storage with some random numbers. Good. Now all the rest of the settings can be left as their defaults, and now we can click on Review and Create. And then we can create. Now it may take a few moments to create the storage account, so let's wait for it to complete. Alright, now that our storage account is created, let's click on that handy Go to Resource button so that we can add some data to it. Now on the left-hand side, we see all sorts of options. What we want to do here is add some dataset files, so let's scroll down to the File Shares option and click on that. Now obviously we don't have any file shares, so let's go ahead and create one. To do that, click on the Add File Share button at the top of the screen. Now our file share is going to contain Microsoft's bike rental data, so let's just call the file share Bike Rentals with no spaces or dashes. Now we'll leave the rest as the defaults and we'll click on the Create button at the bottom of the screen. With our file share created, now we can add files to it, so let's click on the Bike Rentals file share. Now at the top of the screen, there's an Upload button, so let's click on that. Now here we're asked to upload a file. Now I've already downloaded Microsoft's Bike Rental CSV file, so I can go ahead and select it from here. But don't worry, we'll provide that file along with this demo in the doobly-doo. Alright, so now we have a file in our file share. But before we can use it, we need to have an access key. So let's go back to our storage account and click on the Access Keys option. Next, copy the key 1 value. You could also copy the key 2 value if you want, but you can copy it into Notepad or you can just keep it into your clipboard. We're going to be using it right away. Excellent. Now we're ready to use our file share, so let's head over to the Machine Learning Studio. To do that, we'll navigate to the resource group, select our machine learning resource, and then click on the Launch Studio button. Perfect. Now along the left-hand side, we can see a bunch of different options that we can select, and what we want to do here is create another dataset. So let's click on the Datasets option under Assets. Now we can choose the Create Dataset toolbar option, but this time we'll choose the From Data Store option. Let's set our dataset name to show that it's coming from a file share, so I'm going to go with Bike Rentals File. Then we can leave the rest as the defaults and click Next. In the data store selection step, let's choose to create a new data store. Now let's give our data store a name. I'm going to go with bike rentals file with no spaces or dashes. Next, let's choose the Azure file share from the data store type selections. Now we can choose our storage account that we created earlier. Now we can enter the name of the file share, which for me was bike rentals. Now we can paste our access key into the account key field. And now we can click Create Data Store. Good. Now we need to provide information about where in the file share we can find the files that we care about. In our case, we want all the files in the file share, so we're going to provide a path of /*. And we're going to click Next. Excellent. The Settings and Preview step is seeing our file. Now let's make sure that we select that there are column headers and then click Next. Now in the Schema step, we're going to make sure that all the columns are turned on except for Path, and then we'll click Next. And finally, we can click Create. Now the dataset may take a few moments to create, so let's wait for it. Alright, now we have another dataset. So let's confirm that. Let's click on the bike rentals file. And now let's click on the Explore tab. Alright, so much beautiful data. Let's keep it going. In this demo, we're going to load a dataset from blobs stored in an Azure storage account. To do that, we're going to use our existing storage account to create a blob container, add Microsoft's bike rental file to that container, and then use Azure Machine Learning Studio to connect to that dataset. We'll know our dataset has been created when we can explore it in the portal. And just like files, being able to connect to blob storage account is great for situations where you want to add more and more data for AI processing later down the road. So as usual, let's go and head over to our Azure portal. Now we want to add blobs to our existing storage account, so let's navigate to it. We'll do that by going to the resource groups, selecting our resource group, and then clicking on our storage account. Now on the left-hand side, we can see all sorts of options, and what we want to do here is add some blobs. So let's scroll down to the Containers option in the Blob Service section and click on that. Now obviously we don't have any containers yet, so let's go ahead and create one. Now to do that, we click on the Add Container button at the top of the screen. Now our container is going to contain Microsoft's bike rental data, so let's just call the container Bike Rentals with no spaces and no dashes. Now we'll select Container from the Public Access Level option so that we can bypass some of the security policies and make this easier on ourselves. And now we can click the Create button at the bottom of the screen. Now with our blob container created, now we can add blobs to it. But there's a bit of an annoying bug in Azure, so before we do that, we actually need to refresh the browser first so that our access level sticks. Alright, so now we can click on our container. Now at the top of the screen, there's an Upload button, so let's click on that. Now here we're asked to upload a file, and I've already downloaded Microsoft's Bike Rental CSV file, so I can go ahead and select it from here. Don't worry, we'll provide that file along with this demo in the doobly-doo. Alright, so now we have a blob in a blob container. But before we can use it, we need to have an access key. So let's go back to the storage account and click on the access keys option in the left-hand menu and copy the key 1 value. Now, as you can see, it's the same key that we used before because it's the same storage account. Okay, now we're ready to use our blob. So let's go over to our Machine Learning Studio. To do that, we'll navigate to the resource group, select our machine learning resource, and then click on the Launch Studio button. Perfect. Now along the left-hand side, we can see a bunch of different options as usual that we can select. And now what we want to do here is create yet another dataset. So let's click on the Datasets option under Assets. Now we can choose the Create Dataset toolbar button, and once again we'll choose the From Data Source option. Now let's set our dataset name to show that it's coming from a blob. And I'm going to go with Bike Rentals Blob. Perfect. And we can click Next. Now in the Data Store selection step, let's choose to create a new data store option. Now let's give our data store a name. I'm going to go with Bike Rentals Blob with no spaces or dashes. Now we can choose the storage account that we created earlier. Perfect, and now we can select our blob container. And finally, we can paste our access key into the account key field. Now to make things a little more seamless, let's select Yes for the Managed Identity option. And this will make sure that our workspace has the access that it needs, rather than relying on anonymous access. And now we can click Create Data Source. Now we need to provide information about where in the blob container we can find the blobs that we care about. In our case, we want all the blobs in the container, so we're going to provide a path of /*. And then click Next. Excellent! The Settings and Preview step is seeing our blob. Now let's make sure that we select that there are column headers and then click Next. Now in the Schema step, we're going to make sure that all the columns are turned on except for Path, and then we'll click Next. And finally, we can click Create. Now the dataset may take a few moments to create, so let's just wait for it. Looks like it was already done. Now we have another dataset. So let's confirm that. Let's click on the Bike Rentals blob. And now let's click on the Explore tab. Alright, even more beautiful data. Let's keep going. In this demo, we're going to label some data in Azure. Labeling can be used to help classify data in a dataset and help to train AI. To do this, we're going to use the Azure Machine Learning Studio to create an image-based dataset with dogs and cats in it. Then we'll create a labeling project to help identify cats versus dogs. And we'll know our labeling project is set up when we can interact with our dataset in the portal. Now the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource. And I'll do that by navigating through the resource group I called SBTest, and then selecting my SBTest ML machine learning instance. Alright, so right now in the middle of the screen we see the Launch Studio button, so let's click that. Alright, now along the left-hand side we can see a bunch of different options that we can select. Now what we want to do here is create another dataset, so let's click on Datasets option under Assets. Now here we can see all the datasets that we've created so far, but this time we want to create a dataset with a whole host of images in it. So let's go ahead and click on the Create Dataset button and get started. Now we're going to keep this really easy. Rather than creating our own image repository, we're going to use a Microsoft dataset. So in the pull-down option, let's choose From Data Store so that we can use Microsoft's online dataset. Let's give our dataset a name. I'm going to go with SBTest dset. Now let's choose File as the dataset type since we're dealing with image files, and then we'll click Next. Cool. Now let's choose to create a new data store. We have to give our data store a name, so once again I'm going to go with SBTest dstore. Under the account selection method, we're going to choose to enter the information manually. Now all the information in this section is actually provided by Microsoft, so I'm going to enter it all here, but don't worry, I'll provide it in a file in the doobly-doo. Now we'll click Create Data Store. We need to provide the information about where in Microsoft's blob container we can find the images that we care about. In our case, we want everything in the container, so we're going to provide a path of /*. And then we'll click Next. And finally, we'll click Create. Perfect, there's our dataset. Okay, so now we can create a labeling project. To do that, we'll click on the Data Labeling option in the left-hand menu. Of course, we don't have any projects yet, so let's create one. Now we'll do that by clicking on the big Create button in the center of the screen. The first thing we're going to need to do is give our project a name. So now we're going to be totally unoriginal again, and I'm going to give it a name of SBTestLP. We'll use the default image classification multi-class option and click Next. Now here we're asked to select a dataset to use, and here we'll use our image dataset that we just created. So I'll select my SBTest dset option and click Next. Now if we plan to continuously add images to our dataset, we might want to have continuous refresh option. But in our case, we're using a static dataset from Microsoft, so we'll leave the option unchecked and just click Next. Next, we need to set up some label classes. These are the labels that we'll give to each of the images. Now the dataset we're using has dogs and cats in it, so we'll start with 3 simple labels: dog, cat, and unknown. Good, now we can click Next. The labeling instructions step allows you to actually provide a link to a website or type in some details that helps someone to decipher how to categorize your data. For something as simple as dogs and cats, we really don't need this, but there are some images that require detailed instructions to understand how to classify them. Anyway, for us, we're going to skip this step and click Next. Finally, in the ML Assisted Labeling step, we're going to uncheck the Enable ML Assisted Labeling option. The dataset is super simple and we won't need that, so we can select to create the project. Now it may take a moment to create the project, so let's give it a second. Perfect! Now let's start labeling. To do that, we need to click on the icon in the Label Link column. Now once again, this may take a moment to load, so let's give it a second. Alright, look at that! We're seeing some animals. Anyway, what we're going to do here is we're going to be playing the role of a labeler. There might actually be many labelers, and that would be a good thing. What each labeler would do is review each of the pictures and decide whether what they're seeing is a dog, or a cat, or something unknown. With something as simple as a dog or a cat, the chances are good we'll all have the same answer, but that's not always the case. What we're trying to do is give the system information on what tends to be a cat and what tends to be a dog. Then machine learning can take new images and use that labeling to start figuring out for itself if the new image is a dog or a cat. So what we have to do here is go through all the pictures and label them. And to make my life easier, I'm going to select to show as many images as possible, and then label all the cats that I see as cats, and I'll do the same thing for dogs. Now that all the images are categorized, I can click Submit at the bottom of the screen. Now I get another batch of images and I can repeat the process. And I'll do that for all the images and fast forward that for you a bit here. Now there's no need to label all the images that we have, but since there's only 200 in the dataset, I will just for completeness sake. Now once every image is labeled, or we just get bored, we can see what our progress is. To do that, we click on the data labeling option in the left-hand menu once again. And then we can click on the project. In this case, we got most everything done, so we're seeing 81% coverage for 200 items in the dataset. We can also see that the images are about 50-50 dogs and cats. We can also see all the labelers that were involved. In this case, it's just me, but in a normal case, you'd want as many people and images as you can to help train the model. In fact, this is the screen that you can use to export the information so that you can use it for training later. Regardless, at this point we've got an image dataset and we've got it almost completely labeled. Good job! In this demo, we're going to take a look at how you might run some test scripts manually using Notebook in Azure. Being able to run custom scripts shows just how powerful and low level you can be with your data. To do this, we're going to use the Azure Machine Learning Studio to download a sample notebook from Microsoft, and then execute some sample code and view the outputs. While notebooks are focused a lot on being able to execute lots of different code, specifically Python, this demo won't go too much into code detail. The point of this demo is simply to show that you can create and execute code and where to do that. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource. And once again, I'll do that by navigating through the resource group, and then clicking on the machine learning instance. And once again, in the middle of the screen, we can launch the ML Studio by clicking Launch Studio. Perfect. Now along the left-hand side, we can see that there's a bunch of different options that we can select. Now what we want to do here is play with a notebook, so let's click on the Notebooks option under Author. The Notebooks section shows us all the notebooks that we've downloaded, configured, and created. The purpose of notebooks is to be able to execute certain low-level commands to achieve certain outcomes. Just to give an example, I have notebooks that look at all kinds of data from HVAC units. These notebooks can evaluate entire datasets to determine behaviors and tendencies. For instance, I can run a notebook that looks at a dataset and tells me how long it typically takes from the point that I change a setting on a smart thermostat to the point that the facility is at the correct temperature. Using that information, I can then apply logic about expected occupancy. So if I want to achieve a certain temperature by the time there's a customer rush, I have the information to be able to do that. And then once I have that information, I can export and apply similar logic to all of my HVAC units. Anyway, Notebooks allows us to run all kinds of Python code, but don't worry, in this demo we're not going to actually run any code. Instead, I'll just show you where to find samples, how to download them, and how they work. So let's do that. The first thing we'll do is go take a look at the built-in Microsoft samples. To do that, click on the Sample Notebooks tab above the list of notebooks. In this list of samples, you'll find a good set of how-to guides and tutorials. And if we expand tutorials, we can see several different samples. Each of these samples touches on a few different things that you can do with machine learning. For example, if we expand the Create First ML Experiment folder and select a Jupyter Notebook file, we can see some markdown that walks us through the process of connecting to our workspace, loading some data, training a model, and viewing the output. In fact, let's do that. First, we need to clone the notebook. So to do that, click on the ellipsis button beside the Create First ML Experiment and select Clone. Now we can select the Jupyter Notebook file in our own cloned repo, and we'll close the other one so that we don't get ourselves confused. Here you'll notice that there's lots of instructions in each section and then a code block. That's what these notebooks are for. We can create a bunch of Python code that executes certain commands and manipulates and inspects data. This sample from Microsoft analyzes diabetes data. We're not doing anything particularly interesting here, just showing that you can iterate through data and play with it. So what we'll do here is execute each of the commands laid out in this file. To do that, we'll simply scroll down through each of the commands and execute the code blocks in order by clicking on the Run button beside each code block. And finally, when we're done executing the work, we can view the results by executing the experiment command. This will generate a link for us to be able to view the experiment in the studio. So what we're seeing here is the output of Microsoft's sample. As I said, it's not particularly exciting. What we've shown here is that we can execute notebook commands so that we can manually interact with our data and generate certain output. Obviously, all data is different, and what you want to get out of your data is different too. But now you know one of the things that you can do to play with your data. In this demo, we're going to run an automated machine learning experiment in Azure. To do this, we're going to use the Azure Machine Learning Studio to create an automated ML run against the bike rentals dataset we created previously. We'll know our experiment is running once we submit it and Azure tells us it's running. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and I'll do that by navigating through the resource group that we called SBTest and clicking on the SBTest ML machine learning resource. And then we'll open ML Studio by clicking on the Launch Studio button. Perfect. Now along the left-hand side, we can see a bunch of the different options as usual that we can select. Now what we want to do here is set up an automated ML. So let's click on the Automated ML option under Author. Now obviously we don't have any automated ML set up. So let's set one up by clicking on the New Automated ML Run button. On the Select Datasets step, we're presented with the datasets that are supported by the automated ML. Supported datasets are those that have tabular data, and that's why our image dataset doesn't show up here. To keep things as easy as possible, we'll select the bike rentals dataset that we set up by attaching directly to Microsoft's online dataset, and then we'll click Next. In the Configure Run step, we're asked to attach the run to an experiment. Now this can be attached to an existing experiment or to a new one altogether. Well, we've never done this before, so we're going to select to create a new experiment. Now we can name our experiment. Since this experiment is about the bike rental dataset, a name that represents that seems appropriate. So I'm going to call my experiment SBTest Bike Rental. Now the target column selection lets us choose which column we're primarily interested in. This is the column that our model is going to be trained to predict. For example, imagine you had a dataset where one column was text and another column indicated the language it is. In that case, we'd choose the language column as the one that we want the experiment to predict. So in this case, we want the experiment to target the rentals column. And lastly, we'll select our compute cluster that we created before and click Next. For the task type and settings section, we're going to select the regression type. This type tells ML to predict numeric values, so let's select that. In our case, there's a few more settings that we want to provide too, so let's start by clicking on the Additional Configuration Settings link. Now let's select the normalized root mean square error as the primary metric. Next, we're going to want to block some of the algorithms. Ideally, you want to have as many different algorithms reviewing your code as possible, but in this case, we don't need it. Plus, the more we have, the longer it takes to run. So in our case, let's block everything but random forest and light GBM. Now, under the exit criteria, we're going to set the training job time to 0.25 so that the experiment ends after a maximum of 15 minutes. We're also going to set the metric score threshold to 0.008. Good, and we'll leave the rest as default and click Save. Now we'll click on the View Featurization Settings link. Now here we want to make sure that the Enable Featurization is enabled, so make sure the checkbox is checked and then click Save. Finally, we're ready to submit our automated ML. Now when we do that, the run will begin immediately. So let's go ahead and click Finish. Now at this point, we simply wait for the run status to say that it's running. Excellent. Now we finally have some running automated ML. Now just be cautious, these can take a long time to run, though we did cap it at 15 minutes. In this demo, we're going to rerun an automated machine learning experiment in Azure. To do this, we're going to use the Azure Machine Learning Studio to create a new automated ML run against an existing experiment. We'll know our experiment is being run once again when we submit it and Azure tells us it's running. Alright, so as usual, let's go right over to the Azure portal. And we're going to navigate to our machine learning resource, and once again we'll navigate through the resource group. And we'll select the machine learning instance. And we'll open up the Machine Learning Studio by clicking on the Launch Studio button. And since we want to run another automated ML, we can click on the Automated ML option under Author. Okay, so here we can see all the runs that we've done before. And here we see the run that we previously ran against our bike rental dataset. What we want to do here is run this again. Rerunning an experiment is pretty common. Maybe some data has changed, maybe there's some tweaks you're making to algorithms, or maybe there's a whole other dataset that you want to use. To perform another run, we need to once again click on the new Automated ML Run button. Now once again, we're going to select our bike rentals dataset and click Next. Now because this is a rerun, we're going to select an existing experiment rather than creating a new one. So make sure that the Select Existing radio button is selected. Now in the existing experiment dropdown, let's select the experiment that we ran previously. Now this is going to be named whatever you named it, but in my case I'm choosing the SB Test Bike Rental Experiment. Once again, we're going to choose the rentals column as our target column. And then let's select our compute cluster. And now we can click Next. Now in our case, we want our run to be pretty much the same as the last time we did it. Now you might think that this means that we'll get the same results as last time, and we might. But that's not how AI works. Algorithms are deterministic, but AI is based on probabilities. So we might get the same outputs, but it's worth noting the difference. Anyway, what we're going to do here is select the regression type. And once again, we're going to set some additional configurations, the same as last time. So we'll do that by clicking on the additional configuration settings. We're going to select the normalized root mean squared error option. We're going to block all the algorithms. And we're going to set the exit criterion. And then we can click Save. And once again, we'll do the same thing with the featureization settings. Make sure it's enabled, and then we'll click Save. And now we can click Finish. Once again, this kicks off the automated run right away. And now we can watch the run status and wait for it to say it's running. And that's how we'll know that the run is underway. Excellent! We've successfully kicked off another run, and we've attached it to our existing experiment. And it's worth noting that we can do this as many times as In this demo, we're going to evaluate and view the results of one of our best fit model experiments. To do this, we're going to use Azure Machine Learning Studio, select one of our automated ML runs, and check out the results of the algorithm that made the best predictions. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then I'm going to navigate to our machine learning resource, and once again, I'll do that by going through our resource group and selecting the machine learning resource. And then I'll open up the studio by clicking the Launch Studio button. Perfect. Now along the left-hand side, let's click on the Automated ML option under the Author once again. Now in the Automated ML screen, we can see the list of all of our runs. So let's pick the most recently completed run. We don't want to select one that's still running, if you have any that are still running, because they don't have any useful information yet. Anyway, let's click on the run name. Now on the Details tabs, there's a set of boxes that give us information about this run. When it started, when it ended, what algorithms were run, and so on. In the Best Model Summary box, it lists the best algorithm that was run. And below that, it shows us the primary metric that we wanted to produce. In this case, normalized root mean squared error. Beside the calculated number, there's a link to view all the metrics. So let's go ahead and click on that. Now the pop-up shows us all the various metrics that were collected related to our dataset. Everything from the explained variance to the calculated R2 score. And that can be pretty handy. Anyway, let's close the pop-out. Now let's click on the algorithm and take a look at the best model. And now let's click on the Metrics tab. Now here we can see there's a number of charts and KPIs that were calculated based on our bike rentals dataset. If we select the Predicted True option, we can see a predicted versus true chart, which shows us how closely the predicted values correlated to the actual values. The dotted line shows the ideal, while the solid line shows what was predicted. In this case, it looks like the prediction was pretty good. We could tweak the results by making the data better or improving the algorithms. Meanwhile, the residual histogram chart shows the frequency of residual value ranges. Residuals represent the variance between predicted and actual values that can't be explained by the model. Ideally, this hovers around 0, meaning no errors, and here that's pretty much what we see. Here there are very few values that had large variances, and that corresponds with the predicted versus true graph that we see right beside. Now let's click on the Explanations tab. Here we see a chart that explains which feature of the dataset seems to play the biggest role in gaining bike rentals. And the top two explanations that we see are working day and temperature. And intuitively that makes sense. We can probably discount working day because that's actually just 5 out of 7 possible rental days anyways. So that's probably not the reason people rent bikes. But then again, the temperature value is really interesting. It shows that people rent bikes largely based on the temperature outside, and that makes sense, doesn't it? So there you have it. After a run, you can inspect the results and get some insights on your data. With tweaks to algorithms or your dataset, you can gain new insights. In this demo, we're going to deploy our automated ML model as a predictive service. To do this, we're going to use Azure Machine Learning Studio and deploy our automated model into an Azure container instance. We'll know our deployment is working if we can view the deployment endpoint at the end. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and we'll do that by navigating through the resource group that I called SBTestRG and selecting on my SBTestML machine learning instance. And then we'll open up the ML Studio by clicking on the Launch Studio button. Perfect. Now let's go back to the Automated ML section. And let's pick the last successful run that we had. What we want to do here is set up a predictive service based on our best run. So let's click on the algorithm in the Best Model Summary section. Now at the top of the page, you'll see a Deploy button, and this will allow us to deploy our model as a predictive service. So let's go ahead and click on it. First thing we're asked for is a name for our deployment. Well, here I go being unoriginal again, so I'm going to call my deployment SBTest Bike Rental Deploy. In the Compute Type section, you can see that you can actually deploy this to a Kubernetes cluster if you want to. But in our case, we don't have that set up in our demo, so let's just choose Azure Container Instance. And we'll also enable authentication. Now we'll leave the rest as default, and we'll go ahead and click Deploy. Once the deployment kicks off, we can see that the deploy status says that the model is running. That's good. Now we need to wait for it to switch to successful so that we know that it's been deployed. Now this can take a moment, so we just need to wait for it. Alright, now we can see that the deployment status is succeeded. Now our deployment is ready to go. If we click on the name, it will take us to the endpoint definition for the deployment. So let's go ahead and do that. Perfect. Now we see all the information about our deployment. This includes its health, its resource consumption, logs, and so on. Great. Now we're cooking and ready to use it. In this demo, we're going to test our deployed predictive ML service. To do this, we're going to use notebooks to run some simple Python code that uses our service to generate an output. We'll know our test is working if we can view a successful output from our model. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource. So I'll do that by going to the resource group, selecting it, and then selecting the ML project. And then we'll launch the studio by clicking Launch Studio. Now what we want to do here is test our deployed predictive service to see if it can give us some feedback on a dataset that we have. What we've done to this point is we've created a model for bike rentals that predicts how many rentals we'll have in a given day. What we're going to do is we're going to feed another dataset into that model so that it can tell us how many rentals we should expect for that dataset. The way we're going to feed another dataset into that model is to run some simple Python code. And don't worry, I'll give you that code in the doobly-doo, so you won't have to write it all down. But one of the things the code needs is information on how to connect to our predictive service. So before we write any code, let's go get those bits of information. The info we need is actually the endpoint information about our predictive service. So let's click on the endpoints section in the Machine Learning Studio. Note that our deployment is listed here. That's a good sign that we did something right. Now let's select our deployment. Now what we want to do here is we want to grab a couple of bits of information so that we can interact with this deployment. So let's click on the Consume tab and copy the REST endpoint and the primary key value. And we'll store those values in Notepad. Alright, now we can go over to our notebooks. So let's click on the Notebooks option in the left-hand menu. Now what we're going to want to do is execute a single block of code. So we don't need to do anything super complicated here. So let's just go ahead and create a file by clicking on the New File button in the toolbar. Now we'll need a name for our file. Now since I'm still an unoriginal guy, I'll name the file sbtest bike rental notebook. Next, we'll specify that this is a notebook file type. And now we can go ahead and create the file by clicking Create. Now notice that at the top of the screen there's a selection for compute. If our compute instance from earlier isn't the one that's selected, well then make sure that it's selected now. Okay, so now we're presented with a simple rectangular box in which we can type out some commands, some markdown, or even just some code. I'm going to go ahead and input some simple sample from Microsoft that will interact with our deployed service. And again, don't worry about this code, I'll include it in the doobly-doo. Now let's take a quick walk through what this code actually does. First, it creates an array of data, and if you look closely, this data is the exact same format as the bike rentals dataset that we have, and that's on purpose. This dataset represents rental entries. Next, the data is serialized into JSON and transmitted via POST request to our deployed service. And these commands will require our endpoint information, which you can see is needed at the very top of the code. And we'll get into that in a second. And lastly, the response from our service is parsed. If the response was successful, the predictions for each day are written out on the screen. Of course, if the response is not successful, the failure is printed out on the screen. So let's go ahead and paste our endpoint information into the proper spots at the top of the code block. First, the endpoint will go into the endpoint slot, and the key will go into the key slot. Good. Now we can save our file using the Save button in the toolbar. Perfect. And finally, we can execute the code, and we can do that by clicking the Run button beside the code block. Excellent! The code executed and got some results and printed them out onto the screen at the bottom of the screen. This means that our code successfully interacted with our deployed service and got back some predictions for the data that it submitted. Great job! In this demo, we're going to go over some of the features available for managing compute and data stores in Azure Machine Learning Studio. First, we'll take a look at the data stores and how you can manage them. And then we'll look at the various types of compute and how you can manage them too. We'll conclude the demo by changing our existing compute cluster to allow for more nodes. Alright, so once again, as usual, let's head over to the Azure portal. Then we're going to navigate to our machine learning resource, and I'll do that by navigating through the resource group and selecting the machine learning resource. And then we'll go to the studio by clicking on the Launch Studio button. Perfect. Now the first thing we want to do is check out our data stores, and we can do that by clicking on the Data Stores option in the Manage section to the left. Now data stores are secure connections to various datasets. In fact, in our list we can see the connections that we made to our Azure storage account for the file share and another for blobs. The list of data stores tells us which storage account we're connected to, what type it is, and who created it. So you can also see that the connection we made to Microsoft's bike rental dataset is blob storage. We can click on any of these data stores for more information, so let's click on our own blob storage account. Now we can see the details of the data store. We can see its name, who created it, the URL, and even some authentication information down at the bottom. We also have a couple of options at the top. If we had generated a new set of keys for our storage account, we could update the credentials here by clicking on the Update Credentials button and giving it the new key. On the other hand, if we no longer required a connection to the storage account at all, we could simply remove the link by clicking on the Unregister button. So as you can see, managing data stores is pretty trivial. There's not much to do there. Compute, on the other hand, offers more options for management, so let's go ahead and click on the Compute option under the Manage section. The Compute page shows 4 different types of compute that you can play with. The first is Compute Instances, which is individual VMs that you can use to run things like notebooks. Next is the Compute Clusters, which is clusters of VMs that you can use to run things like model experiments. Then there's the Inference Clusters, which is usually used for model inferencing and only really supported for Kubernetes anyways. And lastly, there's the Attached Compute, which allows you to bring your own compute to the mix. To this point, we've created a compute instance and a compute cluster. In both cases, you can manage your compute by adding new compute or editing your existing item. To demonstrate, let's edit our existing compute cluster, and we can do that by clicking on the Compute Clusters tab, and then clicking on our cluster. The first page we see gives us a bunch of information about our cluster. Here we can see that our cluster is mostly idle. Now that makes sense because we haven't used it that much. But beyond that, we can see the available resources, the number of nodes it can run up to, its region, and even how many nodes are currently active. But if we want to change any of that, we need to click on the Edit button at the top of the screen. Now, as you can see, there are certain properties of a cluster that simply can't be changed, specifically the VM size and region. If you wanted a different VM size, your best bet would be to create a whole new cluster, migrate your various connections to the new cluster, and then delete the original one. However, if you're satisfied with the VM size and region, you do have the ability to change the number of nodes that can be run at any given time. So let's do that. Let's pretend that I don't like this silly idea of only one node in a cluster, and that I want some redundancy. In that case, I can simply take the maximum number of nodes slider and push it up by 1. Then I can click Update at the bottom of the screen, and Azure will adjust the settings for my cluster. Perfect, that's it. At this point, now I've got a compute cluster with a maximum of 2 nodes. In this demo, we're going to go over some of the features available for managing datasets and experiments in Azure's Machine Learning Studio. First, we'll take a look at datasets and how you can manage them. And then we'll look at the experiments and how you can manage them too. We'll conclude the demo by adding a simple chart to our experiment result to visualize some data. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and I'll do that by navigating the resource group and selecting my SB Test ML machine learning resource. And then we'll open up ML Studio by clicking on the Launch Studio button. Perfect. Now the first thing we want to do is check out our datasets, and we can do that by clicking on the Datasets option in the Assets section to the left. Datasets are just that, sets of data that can be used to train models. In the list, we can see our bike rental datasets and our cats and dogs image dataset, and we can tell from the list that some of these datasets are tied to data stores. One is tied to an online data store. Our bike rental datasets are tabular, and our image dataset is file-based. From this list, we can create new datasets, or we can manipulate existing datasets. For example, let's go ahead and click on our image dataset. In the image dataset, we can see some information about it. We can see how big it is, what version we're using, and any tags we might have. If we don't want the dataset anymore, we can unregister it at the top of the screen. On the other hand, if we want to create a new version and upload new content, we can click the New Version button at the top of the screen. However, a more interesting thing to look at is the Explore tab, so let's click on that. The Explore tab shows us a preview of the data in the dataset. So here we can click through a few of our files and get a preview of what's in those files. We can get the same thing if we look at tabular data. Now it's important to see that we can't edit this dataset. If we want different data, we need to create a new version and upload the data we want in the dataset. This ensures a certain amount of data integrity for any connected model. Alright, now let's take a look at some experiments. To do that, we'll click on the Experiments option on the Assets section. Experiments are the results of various algorithms that are run against datasets to determine some desirable information from those datasets. Remember that we created an experiment to predict the number of bike rentals that we would have per day based on weather conditions and time of day. Experiments run chosen algorithm against a dataset and generate an optimal model based on predictions versus actuals. Then the model can be deployed for use in the real world. In our experiment list, we can see a simple experiment that we ran for diabetes data, and another that we ran for bike rentals. So let's take a look at our bike rental experiment by clicking on the experiment name. In the experiment screen, we can see all of the runs that were performed. And here we see our first run, and then the rerun we did soon after that. The list may have many runs that were based on different data sets or different algorithms. In our case, we didn't make any tweaks between the runs, so the results are effectively identical. Regardless, this screen can show me information from the runs that can help me determine their effectiveness. For example, let's pretend I really want to see the difference in R2 scores between all of my runs. I can do that in a couple of different ways. First, I can click on the Edit Columns button in the top of the screen. The pop-out shows me two lists. The Selected Columns list tells me everything I'm showing in the Run list, and the Available Columns shows me what I could be showing. So let's search for R2 and then add the max value to my Selected Columns list. And now we can click Save at the bottom of the screen. And now if I scroll to the right of my run list, I can see the max R2 value for each of the runs. Another way I can see the data is to click on the Add Chart button at the top of the screen. In the Add Chart pop-out, I can then select the R2 value in the y-axis list. Then I can leave all the rest as defaults and click Save at the bottom. And now what I have is a chart that shows me the R2 score for all of the runs at once. And this is much handier if I have lots of runs instead of just two. And there you have it. Datasets and experiments. Pretty straightforward to manage. In this demo, we're going to look over stored pipelines and models in Azure's Machine Learning Studio. First, we'll look at models and how you can manage them. And then we'll look at pipelines and how you can manage them too. We'll conclude the demo by creating a very simple pipeline and running it into a new experiment. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and we can do that just through this handy link right in the main page. Then we'll open up ML Studio by clicking on the Launch Studio button. Perfect. Now the first thing we want to do is check out our models. We can do that by clicking on the Models option in the Assets section on the left. In the Models list screen, we can see all the models that have been created so far. At this point, there's only one model that we've created through our automated ML work that we did. However, I can use this screen to navigate all the models I have, delete some unused models, or even create new ones. I can view the details about a model just by clicking on it, so let's do that now. Looking at the model, we can see some information about it. We can see which experiment it was associated to, along with some other identification information. We can also choose to deploy that model so that it can be used in its own predictive service. Of course, we've already done that with this model, so there's no need to do that again. At the top of the screen, there's some tabs that we can see for more information about this model. For example, the Artifacts tab shows the actual model that was generated, and we can download it if we want to. And the Endpoints tab shows us the endpoints associated with this model if we've deployed it. So models are good, and there's lots of useful information there, but there's not a ton of action here. So let's flip over to the pipelines on the left-hand menu for some different fun. Pipelines are a workflow that can connect various machine learning phases together to perform various actions based on requests, timing, or other triggers. Pipelines can be shared with others too. Generally, pipelines are useful to track how a model is performing in the real world. Let's see what this looks like by creating one. In the Pipeline Runs tab, let's click on the New Pipeline button. Now this takes us to the Pipeline Designer screen. This screen makes the creation of pipelines all based on drag and drop. There are ways to do this with code, but this is much easier to get started. That being said, as you get better at this, you'll probably want finer control, so code will be your friend in the end. Regardless, right away you can see that we're asked to select a compute target. So let's go ahead and do that. We'll leave the rest as defaults, so let's just close this pop-out. On the left-hand side is a list of assets that we can use in the designer. Well, the first thing we need is data. So let's open up the Datasets section and add our bike rentals dataset. Okay, good. Now we want to do something with our data. You can see from the asset list that there are tons of things that you can do here. You can transform data, perform statistical analysis, train models, apply Python, detect anomalies, or even interact with external web services. Now we don't want to get too fancy here, just to show what can be done. So let's expand the statistical functions section and add the summarized data asset. Good. Now that the asset has been added, we need to tie the assets together. So to do that, simply click on the connector at the bottom of our dataset and drag it over to the connector at the top of our summarizer. Now at this point, our super simple pipeline is done. So let's submit it by clicking on the big Submit button at the top of the screen. In the resulting dialog, we're asked to connect to an existing experiment or to create a new one. Well, in this case, let's create a new one. Now we'll name our experiment, and with my usual style, I'll call it SBTest EX Pipeline. And then we'll click Submit. Now at this point, the pipeline is submitted, and it's running. And this will take several minutes, so let's wait for it to complete. Great! Now that the run is completed, we can click on the View Run link in the toolbar. Now this gives us some information about the run, but what we're most interested in is the summary data that was generated. So let's click on the Summarize Data module that we dropped onto the pipeline. What we see in the Summarize Data pop-out is configuration information, but we also see a tab called Outputs and Logs. So let's click on that if it's not already open. Now we see a section called Data Outputs. If we expand it, if it's not already expanded, we can see a result dataset. Now we can download that dataset, view it, or just look at it in graph form. Well, let's look at it in graph form by clicking on the little Visualize icon. And here we can see some summary details about our dataset. We can see that there are 731 rows just because of the count field. We can also see that there are 2 unique years and 499 unique temperature readings, and much more insights if we scroll to the right. Now, every time a pipeline runs, a new output is generated. By attaching this to an experiment, we can see those new outputs for every run attached to the experiment. That output dataset can be made available to anything that needs to use it. Now, obviously, in our case, our dataset is sort of useless, but it still shows it's something that we can do. In this demo, we're going to look at endpoints in Azure's Machine Learning Studio. First, we'll take a look at our existing real-time endpoint, and then we'll create an endpoint for our pipeline. Alright, so as usual, the first thing we need to do is head over to the Azure portal. Then we're going to navigate to our machine learning resource, and I'll do that by navigating through the resource group and selecting the machine learning resource. And then I'll open up the ML Studio by clicking the Launch Studio button. Now the first thing we want to do is check out our existing endpoints, and we can do that by clicking on the Endpoints option in the Assets section to the left. An endpoint is an instance of our model that can be hosted as a web service in the cloud or even an IoT module. The point of an endpoint is to be the connection point to our models. In one of our earlier demos, we deployed a model from one of our experiments. That resulted in the creation of a real-time endpoint. That endpoint can be used by anyone with the appropriate credentials. And in fact, we did that when we wrote a simple Python script that interacted with our model. It did that by connecting through our real-time endpoint that we see here. If we click on this endpoint, we can see some additional information. The endpoint gives us detail about its state, its compute type, and which model it connects to, and more. If we click on the Consume tab, we can see all the details that we would need to be able to connect to this endpoint. We can also choose to regenerate our keys here, and this is a good idea to do every so often, but you do need to plan this very carefully. Regenerating the keys means that consumers with old keys won't necessarily work anymore, and that's actually sort of the point, but it's also why you need to be very careful about it. Now, besides real-time endpoints, there's also pipeline endpoints. Now, earlier we created a pipeline that did some really trivial data summarization on our bike rentals dataset. What we can do is make that pipeline available as an endpoint so that it can be triggered by outside users. So let's do that. First, let's click on the Pipelines option in the left-hand menu. Now let's click on the Pipeline Drafts tab. Now here we can see the pipeline that we created earlier, so let's click on it. Now at the top of the screen, we see that there's a Publish button, so let's go ahead and click that. Now in the pop-up, we're asked if we want to create a new endpoint or attach this pipeline to an existing endpoint. Well, since we don't have any pipeline endpoints, let's select to create a new one. Now it's going to ask me for a name, and I'll name mine with my usual style, SBTest EP Pipeline. Then we can leave the rest of the settings as default and click Publish. Good, now we have a pipeline endpoint, so let's go see it. So go back to the endpoints section, and now we can click on the Pipeline Endpoints tab. And there's our endpoint, huzzah! Let's click on it and see what it shows us. So here we can see a slightly different screen than our real-time endpoint. From here we can see the actual pipeline definition laid out in front of us. We can view information about the pipeline, including parameters if we have any, and we can even submit a run right now by clicking on the Submit button at the top. But importantly, you can see there's a REST endpoint shown for the pipeline. That's the important piece. If there's anyone that wants to interact with this pipeline endpoint, that's the URL to use. And so there you go. Now you have datasets, data stores, compute, models, endpoints, experiments, notebooks, and automation all set up. Great stuff. Now just a bit of advice. Since all of this was created in a single resource group, if you want to clean up after yourself so you don't incur more costs, you can do that by simply deleting that resource group that we created. So in this course, we've used the Azure Machine Learning Studio interfaces, features, and functionality to create and manage an AI deployment. We did this by exploring creating an Azure ML workspace, compute resource, and a dataset, ingesting data from Azure storage sources, using ML Studio to label data, using Notebook to run and test scripts, creating and running automated experiments in ML model, deploying and testing a predictive service model, managing compute resources and data stores, using ML Studio to manage datasets, experiments, pipelines, and models, and managing endpoints. In our next course, we'll use the Azure Machine Learning Studio Designer to create and build a custom AI pipeline.